maker.
So, good evening. Thanks a lot to be here in Makerspace, and I hope that you are going to enjoy our today's Software Developer Thursday, on which will be focused on the topic IoT. Before giving the word to our guest, I would like to have a short introduction about the environment, the lab in which we are today, and I would like to give the word to Walter and give some insight about the Makerspace.
Thank you, and welcome to the Makerspace. This place here is the prototyping laboratory of Neue Tech Park. We have a short video that shows what we do, so we will save about 20 minutes because the video is rather short and I tend to speak a lot. So let's watch the video.
Un'officina multifunzionale dedicata all'apprendimento e alla sperimentazione. Uno spazio in cui dare
Un'officina multifunzionale dedicata all'apprendimento e alla sperimentazione.
Abbiamo realizzato molti componenti.
Uno spazio in cui dare vita a prototipi e realizzare piccoli lotti.
Nel Makerspace abbiamo realizzato molti componenti per i nostri prototipi. Abbiamo imparato a usare nuovi processi e nuovi macchinari utilissimi per le nostre attività di ricerca e sviluppo.
circuiti elettronici.
Quasi 100 dispositivi per la lavorazione di legno, metalli, plastiche, tessuti e circuiti elettronici.
Dei propri progetti. I nostri servizi sono efficienti ed economici. La nostra community è fatta di privati, start-up e imprese di varie dimensioni.
Dopo un breve addestramento si può lavorare autonomamente o affidare a noi
e occasioni
la realizzazione dei propri progetti. I nostri servizi sono efficienti ed economici. La nostra community è fatta di privati, start-up e imprese di varie dimensioni. Organizziamo anche numerosi eventi e occasioni di apprendimento e di networking.
Mein Vater ist ein traditioneller Handwerker und war anfangs skeptisch, das digitale Handwerk in seine Unternehmungen zu integrieren. Jetzt weiß er, welche neuen Impulse er daraus gewinnen kann und welche Möglichkeiten sich ihm eröffnen können.
Okay, so we are in a place where
uns die Möglichkeit, neue Technologien und Geräte zu testen. Eine zusätzliche Chance für das Handwerk.
Can develop his prototypes, his idea, and he or she finds all the tools to make them. We have actually 3 kinds of services for doing just that. The first one is our do-it-yourself service. That means you register to the Makerspace. That's like going to the gym. You make a subscription, which allows you to enter these rooms and work. You need to learn how to use our machines for safety reasons, but also, of course, in order to know what you do. And you learn the basics of how to use our machines or the machines you want to use in a safe way. Then you book the machine and you can come here and work on your own or with our help. The first times, obviously, we won't let you loose alone. We will help when help is needed or leave you in peace when you want to make on your own. The second service we have is the Get It Done service. That means you want something done, but don't have the time or the skills to do it, and you can ask us for help. You tell us exactly what you want and what you need. We'll try to understand and formulate an offer, which you can accept, and most of the time it's 3D printing or water jet cutting. So we're making lots of pieces for companies who need them. And the third one is our course and event program. We have lots of courses for using machines, for bringing certain types of, well, maker project into reality. And you can, on our homepage, you can see the calendar and choose what you want and register and come and learn from our experts. What do we have here at Makerspace? This is one of 4 rooms. We have this generic Fab Lab style room with the machines that won't hurt you much. These are mostly digital machinery like 3D scanner, 3D printer, laser cutter. We have the textile corner here with a CNC embroidery machine. We have a vinyl cutter, we have a printer to print on almost anything. We have electronics and so on. We have a small wood workshop with a CNC router in order to make furniture if you want. We have a small metal workshop where you can work with various kinds of metals, like turning, cutting, milling, grinding, welding, and so on. And in our 4th room, we have the big water jet cutter, a machine that can cut, well, if you can lift it, you can cut it. So it cuts also some centimeters of steel if you need, or glass, or stone, and so on. This speaker here, for example, is made entirely in the Makerspace. It has a front, which is natural stone, water jet cut into shape. The sides are pressed with our membrane press, so they have a 3-dimensional form. There are parts that are milled, laser cut. There is electronics inside made here, and so on. So the Makerspace wants to be a place where you can make also complex prototypes all in one place. And you don't need to wait weeks for your suppliers to give you your singular prototype and pieces, which, as we know, are always difficult to get. You should find almost anything here. So if you're interested to see more, you can come and visit us. Please ask us first. Just write a mail and then come here. Or go to our website where you can find lots of information. Are there any questions? No, so maybe in the end, if you want to, Daniel can show you also the other rooms. I have to leave now, but yeah, I wish you a very interesting workshop here in the meantime.
Thank you, Walter, for this introduction. And so let's introduce our guest speaker, Marco Mantoan, from the Swiss company Occupancy. I hope I have said it correctly. And he's technical solution provider or something like that at Occupancy. And he will make, let's say, a nice journey in the world of Internet of Things. So I hope that you can provide, let's say, this introduction of this fascinating topic, and of course, telling us what you do at Occupancy. Okay. So.
Thank you, Roberto. Thank you, Noitech Park, for inviting me. Well, I'm very happy to be here for talking about data mining in IoT. To introduce you to a project that we did that took us from sensors to insight. Well, basically some words about me, myself. I'm originally born here and grown in Bolzano, and I also started my working career here, and then well, my history took me abroad, and now I'm working for Occupancy in Zurich. I'm passionate in technology, science, and as you can guess from the picture, mountaineering. So what I do at Occupancy, as Roberto told you, I'm technical solution architect, so I am involved in finding new solutions that we can propose to the market and to our customers. I am in contact with our customers, and I make the bridge between our sales department and the product management and development of our company in order to develop new solutions for our customer together with them to satisfy their needs and to get the best out of our platform that we will introduce you afterwards. And I basically do also the project management for the complex project that we have and that we can deliver to our customers in order to organize the delivering of the project, to organize the setup of the devices and the entire project management if we involve, as in this case, external partners. Well, call me if you need a platform to manage IoT projects. If you want to go digital using IoT, but you don't know how, and this is basically what most of the company are in need at the moment. And also, if you want to go climbing, I never say no, so drop me an email. But let's go directly into the topic. So, what is basically IoT and what we do at Occupancy as a company? IoT is not only the device. IoT is much more than a device, than a group of devices and connecting devices. You probably may have in mind that you just needed to connect some devices to get some data, some sensors, but actually what you see here on the right side is the IoT stack, and you can already get the idea that IoT is much more than just devices, especially if you wanted to implement it in an environment that is an enterprise system. So starting from the devices, well, devices are already a word by themselves, because devices are the word, are the connection, the bridge to the world, are connected, are our sense in the world. And so devices are very different from each other. You can never know what you have to expect from our customers. We have customers that have air systems for working in dangerous environment, conveyor belts, people counting solution like the one that I'm presenting today, smart cleaning solutions, smart metering, industrial IoT, which is an entire world as well. And so devices are really a huge word, and especially if you go in interfacing your system with old systems, so making retrofitting like we did for a big customer of ours, Georg Fischer in Switzerland, retrofitting valves for piping systems. This is another word. So you can never know what expected from your customer, from your project, and this is actually the funny thing of IoT. On top of that, you have communication protocols and networks. So communication protocols like MQTT that you already heard about in one of the last Developers Thursday, COAP for narrowband IoT, the always good HTTP connection, LoRa, which is actually one of the most important connections at the moment for IoT, a very low power and unlicensed network to build IoT projects. And also, well, GPRS, LTE, and 5G, which are well known in the market and are still very good options, especially in combination one with each other to develop IoT solutions. On the top of that, you have the device management, which can not be so important if you are just starting your IoT project, but once your IoT project grows, then you have to manage devices. If you are growing up to 10, 20, 100, 1,000 of devices, you need a proper device management. You need to understand, to know how your devices are behaving, how many data are they sending, and to structure them in groups and to organize them in the specific area in which these devices are installed, to track them into the areas that they are installed. So there is a lot that you have to manage about devices, and this is a very important part of the IoT stack, especially as, again, if you are growing your project. And of course, what follows is data management. A large amount of devices generates a huge amount of data. And data management is very important, especially in IoT, because in IoT project, the data quantity can rapidly explode. If you are growing in a number of devices, the amount of data is rapidly growing. And so data management is very important in an IoT project, especially if you consider that the IoT, that this IoT level is just in the middle of what can be a solution. And if you want to forward this data to third-party system to analyze this data, as we will see shortly, you have to harmonize this data, you have to decode this data. For instance, for LoRa devices, you're not getting a readable output from these devices. You are getting an hex payload, which has to be decoded. And so it has to be done into your IoT solution in order to get human readable data out of it. Security management, this is actually something that involves the whole stack, but especially at this stage, security management is very important when your IoT project grows in order to manage user access and to manage who has access to which data, to which devices, in order to cluster your projects for your customers, in order to avoid that someone can read data out of other devices. IoT has to be natively secure. For instance, with LoRa, you have a native encryption of data starting from the connection, because you have to put API keys in order to establish the connection, so data are natively encrypted. MQTT also support TSL in order to encrypt data. So that's why it's spread all over the stack, but at this stage, it's also important to manage user rights and roles. And then at the top of the IoT stack, we find the analytics platform and the business solution. I put them together because these are quite interchangeable parts, because you may have to forward your data to an analytics platform like InfluxDB, for instance, in order to get out insights out of your data. Or you have to forward this data to an ERP like Dynamics 365 from Microsoft, to SAP, or enterprise systems in order to collect this data and take a business value out of it. The business value is the real core of an IoT solution. And what gives value to your business starting from an IoT solution? Well, in my opinion, what comes from the real world, which are basically data, should have been treated in order to get a service out of them. And the service is what you get back to the real world in order to generate your business value. So the business value is basically has to be extracted from data. And the service that you're getting out of it can be an internal service, so improving the quality of your work or of your employees, like it could be, and we will see here, an air quality solution, which is basically a commodity, or can be a more complex system and solution to provide services and advantages and business value, therefore, for your customers. Well, this is what I call a commodity, because air quality solutions are, well, quite easy to set up. This is a dashboard of 3 sensors in my home, actually. And these are very simple, and the value that you can get out of this data is quite immediate. So you can get the temperature, you can get the humidity. If you have a very advanced sensor, you can get also the CO2, and like in the orange square, and the VOC, so the pollution of the air. And well, the advantage is, especially in this moment, to understand if there is the right interchange of air inside the room, that if the quality is good enough, and if you have to improve it, how you can improve it. So the advantages of this kind of solution is basically clear. What was not clear at the very beginning was in this project that we did for ZW. ZW is the Zurich University of Applied Science, and they came to us asking for a people counting solution. We had to start a POC with them, so we had to start from basically 4 sensors in 3 different rooms. That means that one room had 2 entrances. These are people counting sensors that I will show you afterwards. And they came to us because they wanted to know how many people were entering and exiting from selected rooms. They wanted to obtain the real occupancy per hour in correlation with the booking system event, so it's a booking system for the rooms, in order to understand if a booked room was also used and how much it was used. And also to identify the purpose of the room occupancy, so in combination with the booking system, if the event was official or unofficial. So if there were just students studying there spontaneously, or if it was an organized event. And in the end, and from that they thought to get the business value, to check the efficiency and the accuracy of the booking system, and also how many rooms they actually needed. But that was not that easy at the very beginning, starting from the basic data of understanding what does an occupation mean. So let's imagine that here with us, if someone enters and looks inside, is not interested and goes away, okay, it's, the room was occupied or not, from how many people. And so this was the very first one that we had to assess. And we had to work with the facility management of ZW, and what they asked to us was to implement not only the IoT solution in terms of sensors, data management, but also the very top of the stack. So also getting the right insights from this data. Talking about what we do at Occupancy, we are proposing our IoT platform to the market in order to build an IoT project by yourself. We also implement projects for our customers starting from our platform, and we propose our platform as a transversal platform in order to, as a transversal middleware, in order to build on it your IoT projects. It was founded in 2017, it's privately funded. We are 25 people and counting, more or less at the moment, divided between Zurich and Belgrade. And our goal is to propose our low-code platform to the market in order to build your IoT projects. We are able, through Occupancy, to manage different IoT inputs. So we are agnostic from the point of view of the devices, so we are very flexible in the input side. We provide connectivity as a service for different providers like Swisscom in Switzerland, but also Activity. This month we are starting with EveryNet, which is also present in Italy, for sure in Trento, as far as I know. And also cloud-to-cloud solution, like maybe you know the new disruptive technology sensors, which are really tiny sensors, really interesting, and also Yancy, which are also producers of very interesting sensor solutions. As we are flexible in the input, we would like to be flexible in the output as well. So that's why we provide cloud-to-cloud native connectors for Microsoft Azure, for InfluxDB, as already told you, for getting insights out of your data, and also Amazon Kinesis, AWS, and Google PubSub, Webhook, to be more flexible in sending data to cloud systems, and also notification systems like Teams, the classic SMS, email, but also Slack. So in order to have the the flexibility that enables you to have to build your project and to make your project grow, independently from which sensor you choose, from which technology you choose in terms of connection or protocols. Having a look to the Occupancy data processing pipeline, we start from the setup of the sensor. So we set up the data for what we call data flow. So what it's actually the setup that connects the sensor to the cloud and defines how data are decoded inside the sensor. As I told you, for instance, from LoRa devices, you're not getting a readable output, so you have to decode it. So how to connect your data by defining the device in your inventory, in which you can tag the sensor, grouping it into groups, and assign it to specific users or to specific workspaces, and how you process your data. So how you harmonize your data, how you get the value out of your raw data. And as we have seen in the output part, how to forward your data. So where have your data to be stored and to be forwarded to third-party systems. We also have a business logic builder inside Occupancy in order to build up a certain business logic through rules that can be applied to data. For instance, if temperature is higher than X degrees, do that, send this data to a third device, send this data to a webhook, send a Slack notification, send an email, and something like that. And afterwards, for sure, how to visualize and control this data. We have a native connector available on GitHub for Grafana, and this allows our customer to easily visualize data on Grafana as well, or as we're going to see on Power BI, Influx, and some other tools. This is the architecture of Occupancy based on Kubernetes. This is something of which we are really proud of because it's very flexible. It allows us to extend it and to implement new functionalities. We have 2-week sprints in which we implement every 2 weeks new functionalities. We have released, for instance, as I told you this week, the new connector for EveryNet. In the previous sprint, we completely renewed the graphical interface, and this is something of which, as I told you, we are really proud of because it's a robust architecture that we can also develop to other clouds. We are at the moment hosted by Azure, but we can deploy it on Google PubSub, on AWS very easily, as is a Kubernetes cluster, and it's very flexible, very robust, and this is also something that, in my opinion, starting from 2021, which, when we released this new version, it's working very well, and it's supporting all our projects. Projects like the one that we did for ZV, coming back to it, where here I can show you the whole architecture of the project. So we started from the XOVI sensors. XOVI sensors are people counting sensors. They have 2 cameras. They are not forwarding images, so they are GDPR compliant. And they are just sending information about how many people are going inside and how many people are going outside. As connectivity, we have a native connectivity with XOVIS. It's based on HTTPS, so it's encrypted as well. And in the middle, we have Occupancy. In Occupancy, what we did, and I'm going to show you afterwards, is also the summation of this data. So as I told you, the XOVIS is only telling us 1 people went in and 1 people went out, 2 people went in, 2 people went out. But how many people are actually in the room? This is something that we have to get out of this event. And this is done in Occupancy through the component that we call device type, which decodes the data, and in the rule engine, where I said we apply the business logic, we are summing this data. The rule engine is basically no-code block builder for your rules. And here, maybe it's a little bit more for you to read out, but here we can define simply in JavaScript how we can treat this data that we are getting from the devices. And in this case, we are just summing this data, saying, okay, when people went in, how many people were inside in the room before this event. 2, okay, now we have 3 people in the room. And this is the rule engine in which the block here is basically what you have seen here in JavaScript, is showed in this block, where we have the input from the service sensor. We have line count and people in, line count people out, and what we get is the result of how many people are actually in the room. This is visible in our message log, where we have people in is 1, so we have 3 people in total in the room because 0 people went out. In the next message, also in the previous message, we had for sure 1 people in, there were 2, and now there are 3. But this was not enough. Of course, if we had only the number of people inside the room, it was not enough for getting the real understanding of how many people, not how many people, but how much was this room really occupied. Why? Because you have also to count on the time, and as I told you, you have also to compare it with the booking data, and this is something that has to be built in a data model. So we asked to a partner of ours, Valorando, a company that helped us through the expertise in BI solutions in getting the real value out of this data, in defining the real KPIs that we needed to have the real business value, to get the real business value out of this data. So what you see here is basically the data model that we have built in Power BI, but specifically what we did was applying EAX calculations in order to manipulate this data to get these KPIs. So basically each time that a person enters the room, the service sensor sends an update, as I told you, of +1. And this data is aggregated from Occupancy. So what is important to define, as I told you, is the duration of the occupation, because how many people are in one room doesn't tell us how much the room was really occupied. And so we had to calculate the duration of the occupancy, but not only, to split this duration entire one day in order to understand in one day, in comparison with one day, how much the room was actually occupied. And furthermore, the percentage of the occupation in one day. But not only, because we also had to get out measures out of this data. So to understand the real occupation, which was given from the weighted occupancy. So not the average occupancy, but the weighted average occupancy. So the occupancy related to the time. And the weighted peak occupancy. So in order to understand which is the weighted average and the weighted peak occupancy that we can see out of the data related to a specific room. The last step was taking all this data into a Power BI front end in order to visualize this data and to provide reports to the management of ZV. So the very first overview tells us the total usage distribution of the 3 rooms that we are considering, which are of course can be filtered out of the interface. The usage distribution the booking hours versus peak and average occupancy, and no booked hours versus the average occupancy. And these are all very important data in order to understand how your rooms are occupied and which kind of occupancy you have, if it's, as I told you, an official event or an unofficial event. Drilling down to the data, we have in the room performance visualization the percentage of weighted peak occupancy, and this is the weighted peak occupancy, this line, in this blue line in the middle, and then you have the no booked hours, the yellow bars, and the booked hours, the blue bars. And here down you have the booked versus no booked hours per week. And if you can imagine that this data can be extended to a huge building, so with 100 of rooms, it tells you a lot about how many rooms you actually have occupied. Maybe you can sub-rent some of these rooms because you don't need them actually, but you cannot know it in advance if you don't monitor this kind of data. And so the service that I told you at the very beginning of the explanation is also turning out from the cost saving that you can get of reducing the rooms that you have, or by avoiding to rent additional rooms, because you may have the feeling that you need more rooms, but actually you don't. And this is also visible from the last drill down, where you have the detail of the booking report of the rooms compared to the real occupancy. So you can see from here, given a booking, if the room was actually occupied or not. As I told you, this was the very beginning of the project. So we worked with 3 rooms and 4 sensors. And it already generated a lot of data, because you can imagine each time that a person comes in or goes out, we get one tuple. And you can multiply it for the time of how many people are getting inside or outside from a university, multiplying it from the rooms that you have in a university. It's starting getting interesting in terms of quantity of data. That's why after the POC, we thought about how to make this project scale. And what we figured out was, thanks also to the architecture that the university was implementing, so they were making available data on the booking data on SQL database on Microsoft Azure, and thanks to the output connector for Azure that we have implemented in Occupancy before this project, we thought about extending this project on Microsoft Azure in order to having the possibility to manage a higher amount of data in an easy way, and getting it with good performances as well, in order to don't wait half an hour to get data out of your report. And so from Occupancy through the output connector, we forward data to Azure IoT Hub, where we synchronize automatically all the devices that we have set up into Occupancy directly into IoT Hub. From IoT Hub, we have the Azure Event Grid in order to route the service and react to events that are happening into IoT Hub. And Azure Functions in order to append the new records that are generated from IoT Hub, and to append them into the SQL database, in which we applied the logic that I just showed you that was previously done into Power BI. So the logic that we developed for Power BI, we have recycled it into Azure, into a SQL database, building up views and store procedures to aggregate and to manage data in an easier way. Then, again, Power BI to visualize data, and from Azure is straightforward. And in order to provide the reports, schedule report also to the management, in order to close the cycle and to provide to the management all the needed information that they wanted to manage their facilities for the university. So, well, this was basically my presentation. Thank you again for inviting me here. Hope you enjoyed it. If you have further questions, I'm available. And if you want to drop me an email, here are my contacts. If you would like to try Occupancy, well, the OIRAC Research has a student license from us that is freely available to be used inside the Noi Tech Park. If you want to use it for your project at the university, we can also provide you a student license. If you want to do business with Occupancy, again, you have 30 days free trials to try it out by your own and to start building your IoT project. Thank you very much and enjoy your evening.
So, are there any questions?
How long did the project take, like from the beginning and setup, and I saw that the data monitor was the whole year 2021.
Yeah, exactly. Well, it actually took more than what we expected. Basically because when ZW thought about this project, it was in a very early stage. It was an initiative of the facility management of ZW, and they started thinking about it almost 2 years ago. They contacted us, they tested the sensor for a very long time, and then they decided that they wanted us to make the project for them. And it was funny because, as I told you, we provide Occupancy as a tool in order to allow you to make your project. But then the facility management told to us, no, you didn't get the point. I want that you make the project for me. And so we started to think about how to build it up, and so we contacted Valorando, the partner, because we are good with Power BI, but honestly said, I've never talked about getting out these kind of measures out of this data. For me, it was not so clear at the very beginning that in order to get a real occupancy, we have had to compare it with the time, to get the weighted occupancy instead of the simple occupancy or the peak occupancy. And so all these ideas came from the partner. From the sign up of the project until the end, so to develop the part that I showed you, it took almost 2 months, no more. Thank you.
Any other questions?
Yeah, just curiosity perhaps. You said that there are like 4 sensors for each room, right?
4
sensors for each room.
No, it was 4 sensors in total for 3 rooms. For 3, because one room had 2 entrances. And so this is also part of the rule engine, because if you have 2 entrances, you have to group the sensors in order to have the data aggregated in the message log, in what I showed you. What I showed you here. So if you have 2 entrances or more, you have to know if one entered from one door and had exit from the other one. And so you have to aggregate these 2 data. And this complicates everything a little bit more.
Okay. Yeah, so I was thinking about where do you install these sensors in the, I think it was in the doors, right?
Yeah.
What happens if a kid enters?
If a
kid? A child.
Child, as well. It's recognized from the Xobis. Xobis sensors are really, really reliable at that. These are based on an AI engine that elaborates all the data on the edge. So all the data are elaborated on the device. So no images are, as I told you, forwarded to a server to be analyzed. What you are getting are just points of people. Also, what you can see from the sensor are just points. People coming inside or going outside, and it's very reliable. And if it's not enough, because it depends, you have to adjust and to trigger the sensor really good at the very beginning. So it's not a plug and play. Absolutely, you have to test it for a couple of days. Because at the very beginning, you are getting also what we call ghosts. Ghosts are people that also, if there's nobody in the room, but we are still getting that in the room is there's someone, we assume there is a ghost in the room. So at the end of the day, at the very beginning, we took to 0 each midnight all the counts in order to start again the day after. After a training period, you are really minimizing this amount of code, which at the end of the project are 1% of the total amount of the people that you can still count. So yeah, they are very reliable sensors.
Yeah, and just one other thing. I don't know if you thought about adding some more sensors to the for instance, one CO2 or another sensor that counts the particles per.
Yeah.
I don't know if you thought about that or not.
They've also this kind of sensors by Zetabet.
Because otherwise the people.
Yes, they've also this kind of sensors implemented, and what is good actually, what I'm really proud of for our platform is that you can integrate all these sensors without changing anything inside the project. And if you wanted to change one of these sensors because a new model comes out or it's broken because it happens, you can substitute it very easily. Compared with an Azure solution on which you have to develop the decoder, in which you have to onboard the sensor, in which if you have to substitute the sensor, it's not that easy. It's a huge advantage, especially at the very beginning, so especially in the POC. It dramatically reduced the cost of the POC and for the starting of the project. So yes, they have also this kind of sensors. They can be aggregated with the other data in order to understand, and I think this was the point that you were thinking about, to understand which kind of air quality I have compared to the number of people. This is also very interesting. But I can tell you about, if you're interested, about another project that we're running at the moment, which is based on a smart cleaning solution. So a customer of ours has a certain amount of toilets in their buildings, and they have defined they are a facility management company that actually has to maintain these toilets for this final customer. And they have assumed that a toilet has to be cleaned after, and you can agree or not, 30 usage, for instance, okay, in average. After 30 usage, they have to fully clean it. After 40 usage, they have to make 2 cleans. After 60 usage, they have to make 3 cleans per day, for instance, something like that. We applied door sensors to the toilets in order to understand how many people were using this toilet. And so you have door open, door closed, the people is in. Door open, door closed, the people is out, the person is out. And based on this, they wanted to automatically understand how many clean that they have to do to which toilets. And they compare it with the number of people that in that day were coming inside the entire building. So if you have, I don't know, 100 people inside the building, the average usage of the toilet is X. If you have 1,000 people, the average usage, and you can react properly during the day and plan it forward. If you have a special event, for instance, you can plan it forward how many people you may need, the workforce that you may need to maintain these toilets. And also you can get out the week plan for the people, because you know which toilets are used, how many times per day, and so you can plan in advance how many people have to clean which toilet during the week. And this leads to a dramatic cost decreasing for a company that has to manage 1,000 of toilets in one city or even more. So all these things are very, very interesting. This is actually the most interesting thing for the Internet of Things. And as I told you, you can never know what to expect from a customer. One comes with a toilet, one comes with a conveyor belt, the other comes with a common air quality solution, and it's very interesting.
Other questions?
Do you provide also a sensor solution, or the idea is I, as a client, I set up my sensor network and then Akenza manage the data and more?
Yeah, good question. Thank you. It's often asked. Also, as I told you, we are agnostic from the point of view of the sensors. We have our partners that we consider reliable because we worked for a very long time with them and we know how the sensors work, and that all the sensors are included in our what we call device type catalog. So the list of sensors that we provide already decoded, especially for the LoRa networks. But the customer can choose its own sensor. If it's, for instance, a sensor that communicates through MQTT, you don't even need a decoder, so you can connect it straightforward. I've done, for instance, a tutorial for connecting Arduino via MQTT to Akenza, which is really, really easy to do if you would like to evaluate it's on T-Zone. But we can provide, because some customers, especially enterprise customers, wants to have just one partner that manages everything. And so we provide this kind of service. We purchase the sensor, we maintain the sensor, we install the sensor. But there are customers, for instance, the city of Sasfe, if you have never gone skiing, also from South Europe, to go skiing there, maybe not. But I would suggest you to go there, to skiing in Sasfe. They just said, okay, thank you for the platform, we will use your platform, but we purchase the sensors by our own. So completely free. Flexibility, again, is I strongly believe is the key for the success for most of the IoT projects.
Other questions? If not, I have a couple, if I can.
Sure.
First question that I have, let's consider your example of the project that you provided. So you actually just counted the people entering and leaving. You did not have the amount of people that were, for example, allowed to be, so the full capacity of this room. This kind of data was not stored somewhere in your backend, or yes? And because as also based also on our experience, having this kind of metadata, which are not real-time data, but metadata that could be needed in order to make, for example, calculations on the average occupancy of a room and so on. So if you have an experience on how you can manage this kind of metadata in your platform, I can imagine that your platform can also manage this kind of stuff. But collecting this kind of metadata and updating this kind of metadata is not always an easy task because, for example, your customer is responsible to keep it up to date and so on. So I would like to learn a little bit of your experience. I make all the questions, then maybe. The second one is what I wanted to tell you. Yes, data quality. This is also an important topic. So typically, do you have already, let's say, by default, implement also logics to check if the sensors are working properly? For example, if a quality sensor is sending data which is out completely unreliable, so not really, that you immediately understand they are not providing reliable data. Do you have some logics that also make this kind of control and maybe flag this data, say, pay attention, this data might not be reliable and so on? So did you have experience with this kind of implementations? Because the risk with Internet of Things that you collect a lot of data and you are not aware, you do not have the full control of the quality of what you are collecting. So these were mainly the two aspects that maybe you can a little bit talk about.
Thank you. Yeah, for the very first one, yeah, we had the room capacity given from the client. So it was stored as a variable in the data model, and it can be, like for instance, the mapping of the sensors. So here it was quite easy because it was just 4 sensors in 3 rooms. But in the example of the client of the toilets, we have a database that tells us which sensor ID is placed in which room and in which toilet. So this was you're right. I completely agree. This is hard to be maintained. This is not always obvious, and yes, this can be managed from the platform as well. Also, thanks to what we call custom fields that you can apply to the device in order to say this device is placed in a room of 30 people, so you get this kind of data. But it's very, very important to be maintained, and yeah, in this case it was easy because it was responsible of the client. If it's all on your shoulder, the game changes a lot. So I agree with you, and yes, it's a tricky task. Coming to the second one, yeah, the example of ghost was exactly related to the data quality. So we have a specific variable that tells us how many ghosts we have, and we also had the experience of a sensor which was not properly working, and we got it from the number of ghosts, and thanks to the rule engine, we can get a trigger based on the data that we are receiving, if they are good data or not, so if they are compliant with our expectation or not. But it is more important if you go, for instance, in other IoT applications. Okay, air quality again is quite simple, and you can also get a comparison with 2 sensors, for instance, in order to understand which one is working properly and which one not. But there are also many other, for instance, in predictive maintenance. This is also something that where data quality is very important. For instance, we started working with a company which is developing motor controls, so electric motors controllers, and in that field, the data quality is a problem that you have to take into account, because you have vibrations, because you have also interference from other devices and systems. So yeah, for sure. And but also you can have interference from the network that are affecting the communication, but with this kind of communication maybe a little bit less, but this is also something that can be taken into account, especially in the whole chain.
I don't know, are there any further comments?
Sorry, can you repeat, because
which programming language did you use for the analysis of the data, or your partner?
Okay, also for the very first step, for the data aggregation inside Occupancy, this is JavaScript. This is what we use to define what we call custom rules. Also, the customer is able to define it into these custom blocks. So this is JavaScript. Here in Power BI, we worked with the AIX, which is the native language of data analysis inside Power BI. This is not rocket science. Also, this is also quite easy calculations. Again, easy calculations if you know what you want to obtain. In my example, our customer and even me were not aware of what we wanted to obtain in the end. So the instrument was the less important part of the problem. What was important was obtaining the actual and right KPIs to generate the business value. So here we work with the AIX, which is the language that you can use in Power BI to construct your data model.
You want to add something? No? Okay. So, if there are no other comments, I would like to thank you, Marco, for being here. And maybe we will find some nice cooperation also in integration with our Open Data Hub. It could be nice to... I know, I'm informed. And yes, I would suggest to enjoy a little bit some drink.